So, hey, what's up? So, two very easy multiple choice questions.
Okay.
See if you guys can get
There's
it.
multiple choice.
Okay.
Multiple choice, so it's even easier.
Alright.
So, 3 box trucks, and there's a bowling ball hanging with a string.
Yeah.
So, one of these box trucks is at rest, one is accelerating forward, and one is accelerating in reverse. So, which one is at rest from these 3?
Which one's at rest?
Which one's at rest?
Looks like B.
Yeah, it's the obvious one, right?
Yeah.
Which one's accelerating forward?
And this one?
Yeah.
Yeah.
Yeah, A. You got it. Why would you say A?
It's because once it has rest, when it starts moving, it's gonna look like the ball's like going backwards because it hasn't.
It's on a stay rest.
Yeah, because of inertia. So
Yeah.
the bowling ball's being left behind, you could say.
Yeah.
Because everything is moving, so it's appearing to swing back.
Yeah.
Exactly.
Yeah.
So, all right, you guys got the first one. So the second one, pretty similar,
Okay.
but instead of a bowling ball, it's a helium balloon.
Okay.
So out of these 3, which one is at rest?
B again.
Yeah, exactly. Which one is accelerating forward?
Does that change? I don't think so.
No.
I say A still.
I think when I'm like running with the balloon, it's still gonna be
behind.
right.
The only thing that is different with that is that this is inside a container.
So there's no air pushing back.
Exactly.
I think it's B.
No, B is at rest.
Okay.
So which one's accelerating forward?
Just straight up no.
Well, I mean. Then,
Well, I'm going A, so you can go
you're
C
still,
if
you're
you
still
want.
going A?
Yeah.
I'll go C.
Okay, it is C.
Okay.
So the simple
Yeah.
explanation for that is that the helium is less dense than the air. So when the truck is accelerating forward, all the air inside the truck is also moving through space in that same direction. Because the air is more dense than helium, it's able to push the helium in that same direction.
Alright.
So that's what happens. So here, let me show you this. I actually did this experiment myself inside a cargo van. And I want to see if you guys could tell me what direction did I accelerate this cargo van? To the right or to the left? So the app was obviously more dense than air, and the helium is less dense than air. So what direction did I accelerate? To the right?
right.
Yes, obviously, because that's what buoyancy is. So you guys heard of buoyancy, right?
Yeah.
So it's a chain reaction of a force, buoyancy.
Right.
So matter pushing on something else is pushing something else. So that's a chain reaction of a force. So this one, same principles, but it's a water container filled with water with a ping pong ball and a steel ball. So what direction did I accelerate this one? To the right or to the left?
The left.
Yeah.
The ping pong one.
Yeah. So again, the water, same thing. The water's moving
Pull up my hand too quick.
I'm pushing the water to the left, and the water's able to push the ping pong ball in that same direction.
Right.
The water's moving through space.
Yeah.
Exactly. So let me show you guys one more. So in this one, I had 2 water bottles, again with a ping pong ball and a steel ball. I had them both at rest like this, but I only accelerated one down.
Yeah.
Which one did I accelerate down? Left or right?
Right.
Yeah,
Yeah.
that's the obvious one,
Yeah.
exactly. Because again, the steel ball is being left behind because the water's not able to push it, but it's able to push the ping pong ball down.
Yeah.
And it shows you. So matter will always react to acceleration 100% of the time, always. So let me ask you guys this question real quick. If I have this water bottle like this, for example, and I release it into free fall,
Yeah.
do you believe it accelerated down towards the earth?
The water went
Yeah.
up.
Yeah.
Do you believe the water accelerates down? I
The
mean,
water?
I mean the water bottle.
The bottle?
Yeah,
Yeah,
the whole water bottle. Okay,
yeah.
so here's the thing. The one on the left, is actually free fall, but we can see that there is no reaction to that acceleration.
There's no oxygen or air inside.
No, the fact is, I don't know if you guys knew, gravity is just a theory. So gravity is just a theory because a physical downwards acceleration has never been measured, and the reason why is because matter doesn't react to acceleration in free fall. So there is no measurable force in free fall. So again, if we understand buoyancy is a chain reaction of a force or of motion, if I have a helium balloon here on Earth and I release it, what direction does it go?
Up.
Yeah, it goes up. Why do you think it goes up?
Because it's less dense.
Than air?
Yeah.
Yeah, and again, the air obviously is more dense. It's literally moving in that same direction as well. Up is able to push the helium up. So we know inanimate matter cannot move by itself. So what's pushing on the air to be able to push up the helium?
Gravitational pull.
I don't know.
So again, a lot of people would say gravity, but gravity, first of all, is not a force that can be measured. It's just a theory. And again, if the force was truly acting downwards, then helium balloons wouldn't be able to go the opposite direction. Because if the air is being moved down, the air has to be moving up to be able to push a helium up. So the fact is the Earth that's literally pushing up on the air, which is pushing up on the helium. That's the chain reaction of motion, of buoyancy that we experience here. So the fact is the Earth doesn't exert a pulling force, is exerting a pushing force right now. So the Earth is not pulling you down towards it, it's pushing up against you right now. So again, if I have an object and I release it into free fall, it didn't move down towards the Earth, it's the Earth that moved up to the object. So right now everything's moving up simultaneously. If you're connected to the Earth, then you're moving up. And if something's not connected to the Earth, then it's the Earth that comes up to meet it. So nothing accelerates down in free fall, in other words. So here's the thing. You guys believe the Earth is a ball, right?
Okay.
If we could prove that it's literally the ground moving up, you know, and up is relative on a ball. In other words, if you're standing here, up is this way. If you're standing out here, up is this way. In every direction away from the center. If we could prove that it's the ground moving up, or the Earth, how can the Earth be moving up in every direction at the same time if it was a ball?
That's what I would say is going inwards.
Yeah.
So how can the Earth be moving up like this, up like this, up like this, up like at the same time?
Maybe it's expanding.
Exactly. That's the only way it would work. But the fact is, that would mean the Earth will just explode, because it's not growing by the second. We know that. So in order for people to believe in the ball Earth theory, they first have to believe in the theory of gravity being a pulling force, which doesn't exist. The force of the Earth is a push. So the fact that the Earth is literally moving up, creating the buoyant effect here on Earth, literally debunks the globe Earth. It's the number one proof that debunks the globe. Because again, if we could debunk gravity as a pulling force, then the whole globe Earth model falls apart. Because they need the pulling force of gravity to explain orbits, to explain how we stick to the ball. Again, but if it's the other way around, if it's the Earth moving up instead, then that wouldn't work from a globe. So the fact is, the Earth is a level plane, and we're all standing on that, and it's literally pushing up against us. So again, orientation is singular on Earth, not relative. They're trying to tell us that orientation is relative, but the fact is it's singular. So everybody's vertical here is the same anywhere else on Earth. Everybody's up is the same. So everybody's sky is always above. It doesn't go, you know, if you're in Australia, the sky is not below you.
Yeah.
That's nonsense. That's bullshit, in other words. So if I was to ask you guys respectfully, what's the number one proof that makes you believe the Earth is a ball?
It's what?
Earth's like round.
Yeah, what makes you believe the Earth is a ball? What's the number one thing or proof?
If you go up really high on a mountain,
Yeah.
there's a horizon.
So you think you could see the horizon?
Yeah.
So let me show you real quick. So the only place you're ever going to see curvature of the Earth, first of all, is you guys are familiar with the fisheye lens, like in GoPro cameras, for example. It warps horizontal lines, the fisheye lens. So that's the only place you're ever going to see curvature of people doing high altitude videos, or through CGI images like this. So these are official NASA images from 2002 and from 2012, and they admit that they don't have a real photograph of the Earth from space. They admit that they're all CGI. They make them in a computer. So if you actually elevate, like in a mountain or even 20 miles in the sky without a fisheye lens, this is what the horizon looks like. And there's hundreds of different videos of people sending giant helium balloons with cameras attached to them, and the horizon's always horizontal. If you don't use a GoPro fisheye lens, you use the standard lens. So again, this will be impossible on a globe, you know, because obviously the horizon shouldn't rise with you. It's just if you're looking at the horizon at sea level, for example, like this, when you elevate, that horizon should never rise with you, because it's supposedly starting to curve down. So eventually you should start looking down at the horizon, which you never do. When you elevate, the horizon always appears to rise with you, and it's always in front of you, and it's always horizontal. So again, a physical measurement of the horizon or the Earth has never been done, or to show a curve, in other words. So just real quick, because obviously if we could see the curve of the Earth, we should be able to measure it, right? So the radius of the Earth that they tell us is 3,959 miles. So using a simple formula like the Pythagorean theorem, a squared plus b squared equals c squared, we can calculate how much curvature there should be there based on the radius. So in the first mile, they should be at 8 inches drop, second mile 32 inches, and by the third mile, they should be 6 feet of curvature. So how do we measure for that curvature, right? So easy. We go to a giant lake that's miles across, that's filled with water, and if we actually measure the surface of the lake, it's going to show us that the surface is always going to be parallel to anything horizontal above it, because water, when containing at rest, always forms a level surface, which is horizontal. But they're trying to tell us that the surface of lakes are bending 8 inches per mile squared. So in other words, there's a 6-foot drop in 3 miles, and it's supposedly maintaining that curve. But we understand that lakes don't do that. The surface of water always forms an equal surface, which is level. So this is real physics, and this will be the ball Earth physics they want us to believe. which again doesn't exist. This will be the number 2 proof that debunks the globe. The fact that there is no measurable curvature of the Earth, and the physics of water shows us that.
Air pressure pushing down on this to cause that?
No, because first of all, air is not dense enough to manipulate water. You know, so the air's not, we won't be able to push on water. So the explanation is that the pulling force of gravity is bending the water. That's what the explanation is. But again, gravity as a force doesn't exist. A downwards force has never been measured or detected. And that's because, again, when you release an object into free fall, it's not being pulled towards the Earth. It's literally the Earth that's coming up to meet it. So again, in order for people to believe the globe Earth, they require this belief in the pulling force of gravity. And that's why that's pushed on us so much, even in schools, with the theory of relativity by Einstein. That's his best explanation or take on trying to explain how the Earth is a globe still with no force in free fall. Because the theory of relativity, he claims that it's not a force, but it acts like a force. So now they're double speaking. So again, it's just bullshit, in other words, the theory of relativity. So yeah, any questions for me before you guys go? No? All right, so here, let me give you my channel. You guys can check it out. I go to other universities and talk about this subject, and you can take it too. I have a couple. You guys can take it. Inside of the 6 top proofs that debunk the globe Earth, and then that's my channel in the front as well. So you guys can check it out. All right, man. You guys take care. Oh yeah, definitely. So, no, very easy. 2 very easy multiple choice questions. So 3 box trucks here, and there's a bowling ball hanging with a string. So one of these box trucks is at rest, one is accelerating forward, and one is accelerating in reverse. So which one of these 3 is at rest?
At rest?
Yeah, at rest. So
Space class, your physics, an object in motion stays in motion.
So out of these 3, which one is at rest? Yes, B.
Okay.
Yeah,
Well,
exactly.
that would be obvious, yes.
Yeah, obvious. What
Because this one would be accelerating forward, or this one would be just stopping, and then that's like,
Could we say is accelerating in reverse too?
yeah,
You'll get the opposite effect. So
Yeah.
how did you know this one's accelerating forward? Because that was gonna be my next question.
Because it's moving back.
Yeah.
when it's moving forward, this force is going to go this way.
Yeah.
So because of inertia.
Yeah.
So basically, the bowling ball.
Do 5th graders know inertia?
I mean, that's just a fancy word.
Guys, I'm just a business student.
It's just a fancy word, but if you show us an elementary student, a 5th grader, how Apple behaves, they'll understand that
Yeah.
will always happen.
Yeah.
You know, for example, this is hanging right here, right? If I accelerate in this direction, once I explain it to someone, what direction is the ball gonna swing? Towards the back, exactly. So again, it's very simple, very elementary to understand it.
Yeah.
But we put fancy words on it, you know, that kind of complicated it a bit.
Yeah.
Yeah. So you guys got the first one, pretty good. So the second one,
Second one gonna be harder.
no, it's pretty similar actually, but instead of a bowling ball, it's a helium balloon tied with a string. So out of these 3, which one is at rest?
That is a trick question.
Don't overthink it. It's again.
B.
Yes.
Okay.
Yes, again. Because the balloon's not reacting, it's not moving in any
Yeah.
direction, so that one's at rest. Which one's accelerating forward?
I just don't want to see.
That'll seem stupid for her. A.
Hey, okay, that one's actually C.
I knew it.
So unlike
Yeah,
the
you can
bowling
do
ball,
that.
the air when you accelerate the truck in this direction, the air inside of it is also moving through space because the air is trapped inside. Anything that's less dense in the air it's gonna get pushed by the air.
Oh, okay,
Yeah.
okay.
So the helium, because it's less dense in air, it gets pushed in the direction of the force. So you guys heard of buoyancy, obviously, right?
Yeah.
So that's a buoyant effect that we're experiencing here.
Oh.
It's a chain reaction of motion. So again, the air moving, it's what's moving the helium balloon in that same direction. So here, let me show you this.
I'm not smarter than a 5th grader. Fuck. Business student, guys.
So here, since we understand again, the helium balloon will always follow the direction of the force. Again, I have an apple here hanging with a string, which is more dense than air, and a helium balloon that's less dense than air. Based on what we understand, what direction did I accelerate this cargo van? To the left or to the right? To the right, right? Yes, you guys got it exactly. Because again, the helium balloon shows you the direction the air is being moved.
Yeah.
Because the air is able to push it in that same direction. So it's another one very similar. Here we go. This one is water, a water container with a ping pong ball that's buoyant and a steel ball. So what direction did I accelerate? To the left? Yes, to the left, exactly. Because the water, being more dense than the ping pong ball, is pushing it in that direction, meaning the water is also moving in that direction. So again, matter will always react to acceleration 100% of the time, you know? So let me show you guys this one.
Oh, that's funny.
So 2 water bottles here. They're both at rest, but only one was accelerated down. I only accelerated one of these down. So I had it like this, and I accelerated one of them down. Which one did I accelerate down? The one on the left or the one on the... Yes.
Yeah.
That's the obvious one, because again, matter reacts to the acceleration, and you got the multi-directional motion again.
Yeah.
The steel ball being left behind, and the ping pong ball being pushed down in the direction of the force. Let me ask you this. If I'm holding this water bottle at rest right now, and I release it into free fall, do you believe it accelerates down towards the earth?
Yeah, right. I mean, it's going down faster, right?
Right, you guys believe that, right? That gravity pulls it down to the earth,
Yeah.
right? So here's the thing. The one on the left, it was actually free fall. But we
Really?
can see that there is no reaction of the matter to that acceleration, because I don't know if you guys knew, gravity is just a theory. So a physical downwards acceleration has never been measured. So a force in free fall has never been detected. So that's why gravity is just a theory.
Yeah.
So what does that mean? Well, if we understand buoyancy always follows the direction of the force, if I have a helium balloon here on Earth and I release it, what direction does it go? Up. Why does it go up, you think?
Because it's less dense in the air.
Yes, but again, we understand that the air also has to be moving in that same direction to be able to push something that's less dense. So what's moving the air up to be able to push up the helium?
I
I
don't
haven't
know.
taken physics yet.
Very simple. So the fact
The moon's
is...
gravitational pull.
Hey, that's actually not
Oh.
bad.
Yeah.
That's the first time I hear that. But the fact is, it's the Earth that's literally pushing up on the air right now, that's compressing it, that's pushing up the helium.
Yeah.
So it's literally the Earth moving up that's creating that motion. So you guys believe the Earth is a ball, right?
Yeah.
Like this, right?
It's round,
If we
yeah.
could prove that it's the Earth that's moving up, creating the pressure and buoyant effect of going up, if we could prove that, and up is relative on a ball, in other words, if you're standing here, up is this way, if you're standing down here, up is this way, in every direction away from the center, how can the Earth be moving up in every direction at the same time if it was a ball?
I don't know. You got this one.
How would I get this one? How, does a 5th grader know this?
Well, if you explain it to them, they'll understand it.
Yeah.
So here's the thing. The
That would
fact
be
is...
online. Everyone's be like, oh, that girl's
No, trust me.
These
Trust me.
motherfuckers
Nobody
are
gets this.
stupid.
No. So the fact is that it wouldn't work. Because if it's the ground literally moving up right now and not pulling you down to the earth, then the whole globe earth model will have to be expanded in every direction, which will mean it'll explode. So in order for people to believe in the ball earth theory, they first have to believe in the theory of gravity being a pulling force. But the fact is the Earth's force is a push, not a pull. So right now the Earth is pushing up against you right now. It's not pulling you towards it like a magnet. That kind of force in free fall again doesn't exist. Yeah, again, matter doesn't react to that force or acceleration in free fall because it's not there. So when you release an object into free fall, for example, like that, it looks like the object goes down towards the earth, but that's because everything else is already in upwards motion. So it's everything that moves up to the object.
I feel like I have heard this before.
Yeah, so it's the earth that moves up to this free falling object. So that's why this doesn't accelerate.
I remember that. Yeah.
So that's the reality. So again, that wouldn't work from a globe. So that's the number one proof that debunks the globe, that gravity is not a pull, it's a push of the earth. So the fact is the earth is a level plane, and everybody standing on it, everybody's up is not relative, it's singular. So everybody's orientation is the same. So if you live here in the States, it's no different than in Europe. Everybody's up is parallel.
Yeah.
So there is no such thing as up being relative. That's only from a ball earth concept, which doesn't exist. So if I was to ask you guys respectfully, what's the number one proof that makes you believe the earth is a ball?
Photos.
Okay, photos is usually the number one, usually for most people that do
I
say.
don't know.
But
I've never fallen off the earth, guys.
so here, let me just show you the pictures first. So these are official NASA images. This one's 2002 and this is from 2012, and they admit that these are CGI. They admit that they don't have a genuine photograph of the Earth from space. So all of the images that were shown, they're all CGI. They're all made in a computer. So a photograph from the Earth from outer space doesn't exist, admittedly so. So NASA admits this. So the only place you're ever going to see curvature of the Earth is through CGI images like this, or through GoPro camera lenses or fisheye lenses that curve horizontal lines. So, but if you use a standard camera and you elevate, the horizon will always remain horizontal. You'll never see the curvature of the Earth. If the curvature of the Earth was there, would you admit we should be able to physically measure it, right? If the curvature of the Earth did exist, we should be able to physically measure it, right?
I don't know.
Yeah. So do you guys know the radius of the Earth that they tell us?
No.
It's 3,959 miles. That's the radius.
We should have known this. We took a geology class.
Yeah. So based on the radius of the Earth, using that simple using the Pythagorean theorem, a squared plus b squared equals c squared, using that simple calculation, we can calculate for the drop of the Earth. So in the first mile, they should be an 8-inch drop. Second mile, 32 inches. And by the third mile, they should be 6 feet of measurable curvature. So how do we measure for this curve, right? So if we went out to a giant lake that had water, standing body of water that was miles across, the water is obviously going to be parallel to anything that's level above it. You know, we won't be able to physically measure that curvature, but they're trying to tell us that every lake on Earth is bending 8 inches per mile squared. So in 3 miles, there's going to be a 6-foot drop of that water bending, but that defies physics, because again, with the physics of water, when contained and at rest, will show that the surface is always horizontal, in other words, and that's what level means. You know, there's no deviation in elevation from any starting point and any end point, but they're claiming that level means curve now. So they're going against practical physics, in other words. So this will be the number 2 proof that debunks the globe, that there is no physical curvature that can be measured. You know, and again, other than images, you said you don't fall off the Earth, right? So here's the thing: we have air pressure here on Earth, right, which is about 4.7 psi. So air has pressure. So in order for air to be able to maintain pressure, it needs to be physically contained. So the Earth, in my opinion, is not an open system like they claim. It's a closed system. So that's why the air is able to maintain
That makes a
pressure.
lot of sense.
Yeah.
We're learning about systems.
Yeah, exactly. That's the second law of thermodynamics. It has to do with entropy. So in order to have a vacuum next to a pressurized system, you need a solid barrier separating both. Because as soon as you remove that barrier, equilibrium happens. The high pressure always moves to the lower pressure until there's equilibrium. So the fact that they're claiming that outer space is a negative pressure compared to Earth's pressure without a solid barrier separating the two defies the laws of physics of entropy. So the fact is, in my opinion, the Earth is a contained system, so you can't fall off of it. So we're literally inside like a terrarium.
Correct.
Yeah, so that's what the Earth is. It's like a terrarium that's in upwards motion. So it's literally pushing up right now.
Are you a physics major?
Oh, no. Nah, I'm just a physics enthusiast.
Oh, what's your major?
I actually didn't go to university, so I do this in my free time.
Nice.
Yeah. So again, this is very elementary. So this is why I come out to present this. Very easy.
I don't think I've ever learned
this is not like advanced physics or, you know.
My dad studied physics.
Yeah, like.
So he really likes it.
Right. So again, this is very fundamental. You know, you build off of these principles. This is what you build off of. You know, so basically, is there anything else that you guys can bring to the table that makes you believe the Earth is a ball, besides the images, or any reason to why you believe that? Would it be safe to say that you just kind of believed it blindly just because you were told?
Yes.
Yes, right? That will be the honest answer.
Also, because if anyone here says they're flat earther, everyone's like, what are you saying?
So here's the thing. So the Earth is not flat, it's level, and there's a huge difference. Flat has nothing to do with orientation. Level is an orientation that's perpendicular to the vertical. And the vertical is the force of the Earth. But the force of the Earth is not down, it's up. So it's a push. So again, the Earth is level because it has orientation, because it's in motion. So again, obviously you guys are the flat earthers, right? So over 95% of flat earthers claim the Earth is motionless. So what does that mean? They deny that the Earth exerts a force. So they're no different than the globe Earth. They actually believe that there is a force in free fall that cannot be measured as well. So they believe objects go down towards the Earth, but it's actually the other way around. So that's why they're keeping this whole topic underground, I guess you could say. It's by having this false debate, flat Earth versus globe Earth. They're both believing the same thing, which objects obviously don't accelerate down. They believe that objects do accelerate. So again, without that belief, you can't have a globe. If we could prove that it's literally the ground moving up, that globe couldn't exist, because it would just explode. So that's how they're keeping this whole false debate going. So the whole flat Earth, motionless flat Earth especially, it's all being controlled by the same people that are pushing the globe. So it's no different than Republicans versus Democrats, the flat Earth versus the globe Earth.
Yeah.
So again, that's what they're keeping this.
It was funny. I saw this guy. He was at a Trump rally, and he started interviewing people. Are you a flat earther? And they say yes. And he's like, "What makes you think the Earth is flat?"
Yes.
Like,
and they didn't give a cohesive answer.
Yeah, they don't have a cohesive answer.
Over 95% of flat earthers are dumb as fuck too. They just believe what they were told. Right? And they couldn't explain.
Have you I want to ask them, like, have you ever challenged the the narrative that you're taught to believe? Like, do you have anything else that you're thinking of inside your head?
I don't like to make positive claims about things that I can't prove. So a lot of people like to say, well, how fast is the Earth moving? What's outside of the Earth? And I don't know none of that. What I do know, again, physics shows me that the Earth is a level plane based on the physics of water, and that it's in upwards motion based on the fact that buoyancy shows you the direction of the force.
Yeah, that's correct.
So those two are the only positive claims that I know and that I will make, because I can back them up with physics. all the other logistics about how the Earth is moving, how fast it's moving, all of that to me is irrelevant when it comes to establishing whether the Earth is a globe or not. But it will be something intriguing to talk about after we expose this, to the masses, So, yeah, at the end of the day, I don't know what this place actually is, what this existence is about. I don't know I do know that matter cannot come from nothing, and this is a creation. If you come across an iPhone in the desert, you don't automatically assume that it created itself.
Yeah.
So this reality didn't create itself. So there's definitely some kind of God behind all this, or higher power that created this place and us, in other words. But I don't claim to know what that is, because I don't go into religion. I only go with what I know.
Religious either, so.
Exactly. Well, believe it or not, the globe Earth is the biggest religion on Earth, because religions are based on faith and tell you what the Earth actually is, and that's what the heliocentric model tells you. They tell you about evolution, they tell you about outer space and all of that is just beliefs. It's not backed by nothing physical. So again, it does become a religion at one point because it's based on faith, which again nobody can prove. So yeah, that's why I'm out here, because this is the #1 censored topic online. Again, the fact that even flat earthers are being brainwashed into another belief that they can't even back up, it just shows that how controlled this is. So I'm a minority within the minority. I get a lot of hate I get more hate from flat earthers than globers, even though I'm here exposing the globe. That just shows how brainwashed these people are. Because what happened is that they release like flat earth videos of like of a flat earth guru online, for example, and they just praise that guy now. There's multiple characters, believe it or not, that have like 500,000 subscribers, 250,000 subscribers, and these flat earthers just follow them blindly. Everything they say, and all of these are motionless flat earthers again. And yeah, that's how they're controlling this. People are not thinking for themselves at the end of the day. They're just following a guru, for example. So again, at the end of the day, it's about you having an understanding for yourself, and things that you can prove to yourself based on how reality works. So any questions you have for me before you guys go, or? So
physics, science.
Well, here's another thing. Yes, have you guys heard of Euclidean geometry? So Euclidean geometry is a geometry that is used for construction. So when they lay out railroads or when they build bridges, all the blueprints, for example, are all plumbs and levels, which are horizontals and verticals, regardless of distance.
I heard that architecture, that is part of architecture, is like those blueprints and stuff, is one of the hardest majors, actually.
Yeah,
because you have math, you have art, you have everything in there.
Yes.
You have to do all that shit.
So all the datum lines are horizontal. If there was a curve of the Earth, then after 10, 20 miles, they should take account of the curvature of the Earth, which they don't. All the blueprints show that the Earth is basically a level plane, in other words. So again, Euclidean geometry is what's used, not spherical geometry. So that's another proof, in other words, that debunks the globe.
Yeah, I'm just not knowledgeable to this stuff. Man.
It's very easy once you start looking into it.
There's a reason I chose business, guys.
Oh yeah, business. Yeah, I guess you could say that has nothing to do with
I do
this.
have to take physics and chemistry. So.
Okay. No, yeah, it's pretty fun. Again, physics.
I hate chem.
It's how
I don't hate it. It's just like when you learn that stuff and then it doesn't go through your brain, you're like, what am I even looking at?
It is one of like I will say it is like something that's always just intriguing.
Yeah.
That's the thing, though. If physics cannot be simplified to explain it to a child, then in my opinion, it's either a lie, or we're talking about like advanced physics now. But when we're talking about basic physics, like for example about the Earth, if you cannot simplify it to explain it to a child, then it's pretty much bullshit. Like the theory of relativity. Einstein's theory of relativity is his take on trying to explain why gravity is a force, but it's not a force. So he acknowledges that gravity is not a force, but he came up with the theory of relativity, which is basically the bending and warping of space-time. So he's claiming that space is bending towards the center of the Earth. It's flowing, and that's why we are not able to detect that force, because that's not a force. It's just space-time moving, and that's why an object falls. But the fact is that it's just a theory, and it's just an explanation to try and keep this idea alive of the globe Earth. Again, the fact is the Earth, the force of the Earth is up. It's a push. That's easily understandable. It's really that simple. So,
well, thank you for talking.
So here, let me give you my
equally confused and equally...
Here's my channel. You guys can give it a look. I go to other universities as well, and in there are the top. You could take this with you. In there are the top 6 proofs that debunk the globe. On top of the fact that gravity is not a pull; it's a push. So you can give that a look. And yeah, I'm super censored online, by the way. So this is the only way I could get my channel out.
Yeah.
It doesn't get recommended in the algorithms whatsoever. It's the only way people will come across it. Oh, appreciate it. Thank you. All right. Thank you.
Nice talking to you, man.
Yeah, yeah. Take care.
And what's your name?
My name's William.
Nice to meet you.
Yeah, nice to meet you.
Have a good day.
Yeah, you too. Hey, what's up? You want to give us a shot?
I do.
Yeah, 2 very easy questions. Let's see if you guys can get it.
Okay.
So, here's the first one. So, I have 3 box trucks, and there is a bowling ball hanging with a string.
Okay.
So, one of these box trucks is at rest, one is accelerating forward, and one is accelerating in reverse. So, out of these 3, which one is at rest?
I feel like this is at rest. It's this one.
Yes.
Okay.
Okay, how did you know that one's at rest?
Because it's just not.
It's not swinging, right?
Yeah,
That's
it's
not
not
moving,
swinging.
exactly. So, which one is accelerating forward?
Okay.
Yes.
Okay.
How did you guys know that's accelerating?
When it
Because
goes forward.
it's like shit just goes back. Oh, like when a car goes forward, you're like, oh.
Get pushed back,
So
exactly.
it pushes back the bowling ball. So the backwards one is this one.
Yes,
As they're
yes.
going.
It's because of inertia.
Yeah.
It resists the motion.
Exactly.
So could we say though that the bowling ball is being left behind when
Oh.
the whole truck is moving? The bowling ball is simply being left behind, and the tension's coming from the truck moving forward.
Yeah.
The tension on the string.
Mhm.
It's not coming from the ball swinging itself back, obviously.
Yeah.
Yeah. Okay. Perfect. You guys got the first one already. Yeah. Okay. The second one is pretty similar, but instead of a bowling ball, it's a helium balloon
Okay.
tied to a string. So again, out of these 3, which one is at rest?
This one.
Okay. Yes. Which one's accelerating forward?
Why do I feel like it's a different answer?
I can't think.
I guess so. Is A going forward?
No,
No?
it's actually C. So in this case, the bowling ball is obviously more dense than the
Yeah.
air, so the air is not able to push the bowling ball, so again, it gets left behind.
Yeah, yeah.
In this case, the helium balloon is less dense than the air, so the air is more dense. So when the whole van starts to move forward, the air inside is also moving forward, but because the helium is less dense, it's able to get pushed by the air. So the helium balloon gets pushed forward. So you guys heard of buoyancy, right?
Yeah.
So buoyancy is a chain reaction of motion. Something pushing on something else that's pushing something else. So I guess the less dense always gets pushed by the more dense. So here I have an example here that I did inside a cargo van. Again, based on the principles that we just went over, again, the apple is more dense and the helium is less dense. What direction did I accelerate this van? To the left or to the right?
To the right.
To the right, exactly, because that's what's showing you, the matter showing you. Another thing is that matter always reacts to acceleration 100% of the time. So here I did it with a ping pong ball and a steel ball inside of a water container. So what direction would you say I accelerated?
That one.
Exactly,
Right.
same direction, because again, the bowling ball, that's buoyancy. It goes in the same direction as force, right? So here's one more. Here I have 2 water bottles, again, with a steel ball and a ping pong ball. They were both at rest, but I only accelerated one down. Which one would you say I accelerated down? The one on the left or the one on the right?
Like down.
Don't know, but
Like down.
yeah, as in like vertically. Which one did I accelerate down?
Probably that one.
Yes,
That one?
yeah, that's
Yeah.
obvious because that one shows the reaction. Matter reacts to the acceleration,
Yeah.
and that matter always does that. So the one on the left, it was actually free fall. So I had the water bottle like this, and I released it. So do you guys believe when I'm holding it and I release it into free fall? Do you guys believe it accelerates down to the earth from being at rest when I release it?
Yeah.
Yeah. So again, the one on the left was free fall, but we can see that matter didn't react to that acceleration down. So I don't know if you guys knew gravity is just the theory. So a force that on free fall has never been measured. So matter doesn't react to acceleration in free fall because again, there is no acceleration in free fall because there is no force in free fall, and that's why gravity is just a theory. So again, if we understand buoyancy is a chain reaction of motion or a force, if I have a helium balloon here on Earth and I release it, what direction does it go? Yes. Why does it go up? You think?
Because it's like less dense than like oxygen.
Then the air, exactly. The air is actually pushing it up. So the air.
The same way as like why like icebergs float on top of water.
Yes, the water is more
Ice
dense
is less dense
than the water. Yes, and water is able to push it up. So we know inanimate matter cannot move by itself. So what's pushing up the air to be able to push up the helium?
Pushing the air.
Yeah, because the air has to be moving in that same direction to be able to move the helium, just like with the van experiment.
Like gravity. gravity and sun, like from the sun and stuff like that. I'd say because like that's like that's like air travels in like circular formations. Like
Okay.
It goes up and it goes.
Yeah, so basically, because I know a lot of people would say, oh, gravity, you know, pulling force of gravity. But again, we're being told that gravity acts in the downwards direction, but then buoyancy goes in the opposite direction of the force, which again, it goes against, if the air is being pushed down, it can't push helium up, because the air has to be moving up. So the fact is that Earth is actually pushing up the air, which is pushing up the helium. That's the chain reaction of motion that we experience. So you guys believe the Earth is a ball, obviously, right?
Yeah.
So again, if we could prove that it's the Earth literally moving up, pushing up, that's creating the pressure here on Earth and buoyancy. If up is relative on a ball, and you know, which you know, if you're standing here, up is this way. If you're standing down here, up. In other words, in every direction away from the center. If we can prove that it's the Earth moving up, how can the Earth be moving up simultaneously if it was a ball?
That's a great question. How can it be
Moving up at the same time in every direction.
like in every direction?
Yes, at the same time. If it was a ball.
I don't know.
So that would mean that the Earth will have to be expanding, which wouldn't work. So it actually wouldn't work. So in order for people to believe in the ball Earth theory, they first have to believe in the theory of gravity being a pulling force, which has never been detected or measured. Again, that's why gravity is just a theory. The fact is the Earth, the force of the Earth is a push, not a pull. So again, the Earth is literally pushing up against you right now. You're not being pulled down towards it. So the Earth is moving up through space, literally. But it's not a ball, because again, that wouldn't work. It would just explode. So the fact is, the Earth is a level plane, and we're all standing on it, and it's literally moving up like this. So again, up is not relative, like they're trying to tell us. Up is, orientation is singular, not relative. So everybody's up is the same here on Earth. So if you live in China, if you live in Europe, everybody's up is the same. It's all parallels, in other words. So again, this is the number one proof that debunks the globe, that the Earth, that the force of the Earth is a push, not a pull. Because again, without the pulling force of gravity, they can't explain how a ball Earth even exists. Therefore, you know, they can't even explain how the sun and all of that works in outer space, because all of that is just stories that are backed up by a false premise, which is the theory of gravity. So that's the number one proof. So if I was to ask you guys respectfully, what's the number one proof that makes you believe the Earth is a ball?
When like people are up in space and they kind of just like show like the outside it, you can kind of see the curvature. And the same way with like when someone has like a big freaking like a I don't know, like a selfie stick kind of thing, and they have like a camera, and it's like hella like.
You guys are familiar with like a GoPro lens, a fisheye lens?
Yeah,
for
the
example.
fisheye lens, like you could like, I feel like you can literally see it. Like,
Did you guys know the fisheye lens literally warps an image? It bends horizontal
and
lines.
that's true.
So, yeah, the only place, again, you're ever going to see curvature of the Earth is through GoPro lenses that curve horizontal lines, again, or through CGI images like this. Because these are official NASA images from 2002 and 2012, and they admit that they make these in a computer. So a genuine photograph of the Earth from outer space doesn't exist.
Hasn't been taken?
It hasn't been taken. It doesn't exist. So everything that we're being shown is all CGI, or, again, GoPro lenses that bend horizontal lines, which again, the fact is, if there was a curvature of the Earth, a physical curvature of the Earth, do you know the radius of the Earth they tell us?
I don't know.
So the radius of the Earth they tell us is 3,959 miles, which means there's a circumference, I mean obviously multiplying that times height, gives you a circumference of 24,901. So based on this curvature of the Earth that we're being told is there should be curvature every mile. So in the first mile there should be an 8-inch drop, second mile 32 inches, and by the third mile there should be 6 feet of curvature. So again, based on the numbers. So again, using the Pythagorean theorem, a squared plus b squared equals c squared, we can calculate for that curvature. But if we actually went out to physically measure for that curvature, the physics of water, again, when containing at rest, the surface will always remain level. So a lake, for example, that's miles across will never bend on the surface. It would always form a horizontal surface. But they're trying to tell us that every lake on Earth is bending 8 inches per mile squared, which defies physics.
So 8 inches
per mile
for 1
squared.
mile, 16 inches for 2 miles.
No, it's squared. Because if it was just 8 inches every mile, then that would create a pyramid. But they're telling us it's a curve. So every mile after the first increases more and more and more and more, because it has to come back around. So it's 8 inches per mile squared. Again, using this simple calculation, v squared per v squared, we can, because they're telling us the radius, and we can measure the distance we're measuring over the Earth. So by multiplying this square times this square gives us the drop. Basically, we just once we calculate for the drop, we just subtract the radius, and that leaves us with what the drop should be.
Yeah.
You know.
With the white area.
Yes, exactly.
Yeah.
So again, that curvature doesn't exist. It defies physics. So if I showed you an image of me flying or a video of me flying, would you believe I could fly?
No.
Why not?
Because people can't fly.
Exactly. It's a physical impossibility, right? So all these images that they're showing us from outer space of the Earth being a globe, that also defies physics. And not only that, the fact that they admit that they don't have a real image of the Earth from outer space, that kind of shows that they're being disingenuous, obviously.
So then what's real and what's not? Like
So what is real? That Earth is a level plane, and the fact is nobody knows the true dimensions of it. So how far it extends. A lot of people like to say, oh, where's the edge, right? You will fall off the edge. But here's the fact. The Earth has air pressure, right? 14.7 psi. Again, that's the pressure that's pushing helium balloons up, because air has pressure. Water as well. Water has pressure. So in order to maintain pressure, you need a container. So the Earth is a contained system, in my opinion. So nobody can fall off of it because we're inside of it.
Yeah.
And again, we're being literally physically contained. Now, has anybody found this container, what it looks like? Maybe the military have, but it's not common knowledge at the end of the day, obviously. But again, you can't fall off the Earth because it's a contained system. So other than images from outer space, is there anything else that like triggers you to believe or makes you believe the Earth is long? Because obviously images can be easily doctored, right?
I'd say the Coriolis force.
The Coriolis effect?
Yeah, the Coriolis. Because like I study geography at Santa Barbara.
Right.
So I kind of like know about like the stuff and all. Like the Coriolis force is like, it's supposed to be like a direct result because the Earth is a sphere.
It's spinning.
It's spinning, and it's also a sphere, and like that's how it affects like the flow of the water, the flow of the air, the flow of like everything.
Have you heard of like toilets supposedly?
Yeah, if you're like on one side of the Earth, is your toilet gonna flow this way or is it gonna flow in this way?
Yes. So they've actually done tests that, for example, most toilets in the southern hemisphere are built a certain way so that it flushes in the opposite way of toilets in the northern hemisphere. So they've done tests where they have two different faucets, for example. It doesn't have to be a toilet, it can be faucets. When you fill them up with water and then release the plug, they've shown that they go in opposite directions in the same location. So the Coriolis effect hasn't been proven. Or in other words, the spin of the Earth has never been measured either. So again, that's just, in my opinion, just a theory, again, which is not backed by any practical physics or anything real. In other words, it's just hearsay, in my opinion. You know.
Yeah, because also, from what I've learned too, like in like, because I was studying like more like environmental sciences and stuff.
Sure.
They also talk about it's not just a like rotation. It's like more of like a rotation mixed with like a wobble kind of.
Okay.
And so it's like not like mechanic. It's more of like, I don't know, I guess natural. But
Well, yeah. Again, it comes back to gravity, being the cause. So again, if we could prove that gravity is not pulling objects towards the Earth, and it's literally the Earth moving up to an object. So again, when I have this phone and I release it, it looks like the phone moves down towards the Earth, right? But that's because everything else is moving up towards the phone. So we're moving up right now because we're connected to the Earth. So it's like when you're in a car, if you're inside a car and you black out the windows and you have a bowling ball there and then you accelerate forward, it's gonna look like the ball went to hit you. But in reality, it's you going towards the bowling ball and hitting the ball.
So do you think the Earth is a sphere?
No, it's not.
You think it's flat?
100%. I wouldn't say it's flat because flat has nothing to
Or
do
like
with
not like a perfect sphere, like obviously like
an oblate sphere.
It's
that's
like,
what they say.
It's like bumpy. It's like
right. No, it's not a globe at all because you won't be able to stand on the Earth if you're underneath it. You know what I'm saying? Because you need gravity to be able to get stuck to the Earth. But again, gravity is not a pull; it's a push. So again, us standing on the Earth on a level and the Earth literally pushing up against us is what keeps us on Earth. It's the Earth continuously pushing up on us. So again, if you're underneath that,
if we were right here and it was pushing us, it would just push us out.
So if you're in a ball, for example, on top here, right, and the Earth is moving up like that, pushing up against you, then that means all the people underneath will get left behind. You know what I'm saying? So again, you have to believe gravity is a pulling force that's pulling everything towards the center in order to explain away how we could get stuck on this ball, which again, that force has never been measured. or proven. So you guys know every phone has an accelerometer built in, right? That's how you're able to put it in portrait and landscape. It detects the force of the earth when you're portrait and landscape and your screen switches. That's because an accelerometer is a force detection device. So if you download an accelerometer app, for example, you're able to calculate the force. So if you have your phone at rest and you accelerate this way, it detects an increase in the force. You accelerate in any direction, up, down, it detects that increase in force. However, when you put it into free fall, guess what happens? It goes from 1G to 0. So it detects a deceleration or a lack of force. So even accelerometers in our phones don't detect that force in free fall. So again, that's why gravity has always been a theory, even since Einstein came up, even since Newton came up with their theories, is because again, they're trying to make us believe the Earth is something that it's not. So that's why they push these theories on, and, in schools and everywhere, literally, to make us believe in the globe Earth. Because again, without that pulling force of gravity, you can't even conceptualize a globe, not even on paper. So again, the whole globe Earth model and everything about outer space is fueled by that theory.
So do you think it's like globe-like? Like, do you think
No.
it's
It's
so then what shape is it?
It's a level plane. Again, I don't know how far it extends, and it's being contained somehow. I don't know how the container looks. It could be like some kind of
like
cube.
imagine like this is a
It could be-
circle, like this is the Earth. And
Yes, we're all standing on the Earth, and then it's being physically contained by some kind of barrier, physical.
Okay.
So it's like a terrarium.
So then it's flat.
You could say it's flat, but I would say that that's the wrong term. The correct term will be level, because level is an orientation that's relative or perpendicular to the vertical. So level is an orientation perpendicular to the force of the Earth, which is vertical. Flat is just, you could have a flat wall. You could have a flat slope. The Earth is not a wall or a slope. It's literally the floor, and it's perpendicular to the perpendicular to the vertical force, which is a push. You know what I'm saying? So that's why the Earth is level, because it has to do with motion, it has to do with a force. So again, I know you've heard of flat Earth, right?
Yeah.
Obviously.
Yeah.
So over 95% of flat Earthers claim the Earth is motionless. So they don't claim the Earth exerts a force at all. So they
like the forces of like pushing upwards.
yes, they don't. They completely mock it actually. And that's the mainstream flat Earth. That's how they're keeping this whole thing a debate, because now they believe actually objects accelerate down as well by a magical force, no different than gravity. So the globe Earth and the motionless flat Earth are one and the same. It's the two sides of the same coin, pretty much. So like Democrats versus Republicans, we know they're both being controlled by the same entities, just to keep people distracted. So again, the motionless flat Earth, it's what you've heard of, because that's the only thing that gets pushed in YouTube and all that. This motion of the Earth, I only came across it because I came across flat Earth like 10 years ago, almost 10 years ago, in 2016. And I only came across the motion of the Earth not even a couple years ago, 2 or 3 years. That's how censored it is. So before the motion of the Earth, I would just use water as the proof. Because again, the surface of water doesn't have the ability to hump on the surface. It always collapses and forms a horizontal surface regardless of scale. So once I came across the motion of the Earth and the explanations behind it and the proofs based on buoyancy, it's without a shadow of the doubt, the force of the Earth is a push. It's literally moving up. And that's what the flat Earthers and globe Earthers are trying to stay away from.
I have another thing.
Yes.
And it's also like, and maybe this is also something that's like altered, or maybe it's something that's CGI thing. But have you ever seen those videos where it's like, they take a video of like a ship, and as it's sailing away from the ocean, it like slowly disappears?
Yes. So,
another one.
No,
Okay.
have you heard of you've heard of perspective, right? Like
Yeah.
we do have a limit to how far we can see. So I do have some like images here just to show that or highlight that. Let me see where are they. So here, for
I
example,
want to see everything.
yeah, definitely. So again, these light poles are all the same height, right? But it looks like, because of perspective, that they're getting lower on the horizon, and eventually you won't be able to see the ones that are all the way further away. Again, because we have like pyramid vision again, because we have spherical eyes, so we have spherical vision. So everything comes to a point, and that point is basically the limit of perspective, and that's basically what the horizon is. So again, because we don't have infinite vision, you can see it with walls too here in the hallway, or with rail. We know these train tracks are not converging because train tracks are parallel. But again, the further out they go, they come to that vanishing point. Again, that vanishing point is a limit of perspective, and that's what the horizon is. So again, when boats go over the horizon, again, that's just the limit of how far we can see. They simply go out of sight, because we're not Superman, we can't see forever. So again, the horizon is always level.
So if we could see forever, do you think that we would just see the globe forever?
Yeah, but here's another thing that will prevent us. Atmospheric condensation, I guess you could say.
Yeah.
So that's obviously like moisture in the air. So eventually that gets thick further down you see. So you won't be able to see forever, even if you had infinite vision. It'll be too foggy to look to see forever. Unless you could suck the whole oxygen out of the earth and have infinite vision, then you could probably see China from here. You know, but
Then you wouldn't breathe.
exactly, we wouldn't exist. Exactly. So again, a lot of flat earthers, I like to call them, you know, fake flat earthers. They like to focus on these experiments of just being able to see things too far and stuff like that. But vision alone is not a physical proof of anything. So I don't really focus on those proofs because they're not real proofs. The proof is in understanding physics. Again, water. Understanding that water always collapses and forms a horizontal surface. That cannot be broken. That's because water has property. I don't know if you knew, water cannot be compressed either. So if we have one cubic feet of water, for example, it doesn't matter if you have a 10-ton machine, you can never compress that water. Water cannot be compressed. Just like sand, you can compress sand, right, and make it more smaller. Water, you know, water has properties.
But only
It
to
can
like
be
a certain
compressed.
extent. Like you can't like mix sand like.
I mean, to a certain extent, you
To a
can make it
certain
to maybe to a little point, you know.
Yeah.
Again, but water, you can't do that with water. You can't compress it whatsoever. Another thing about water, again, is that it always forms a horizontal surface. So again, these are properties of water, you know, based on physics that cannot be broken. So again, that's the number 2 proof, in my opinion, that debunks the globe, that water doesn't bend on the surface. You know, and the number 1 proof, again, is the lack of a pulling force of gravity. You know, the fact that the Earth, it's literally moving up. That's the number 1 thing that's being censored right now, and it's the number 1 lie on Earth, because even flat earthers believe, you know, that there's a pulling force of gravity in free fall, which again, it's completely false. So I'm a part of a minority within the minority. I don't know if you could say. I'm super censored online, so my channel is not going to grow anymore. You know, my channel here. I'll give you guys my channel. And do you guys have any questions for me about this subject? Any other questions? You guys can check this out in your free time. That's my YouTube channel. And I go to other universities too. I go to USC, I go to UCR.
You ever go to
Oh, I am a UCR, but UC Irvine. I've been wanting to go to UCLA, but it's kind of like too centric. It's like a lot going on there. Kind of hard.
But I feel like there's a lot going on there where it's like there's already a lot going on there anyway.
Yeah,
you know,
definitely. Yeah, it is. USC, for example, it's not too crazy because, you know, I kind of have my spots that I go there already. I know where to park and all of that. So I do go there often as well. But yeah, those are the 2 main ones here, and USC is where I go. But you guys can check it out. In there are the 6 top proofs that debunk the globe, besides the force of gravity, obviously. You know.
You didn't talk about this one.
Euclidean geometry? Yeah, so you guys heard of blueprints, right? When they do construction. So when they lay out railroads or when they construct bridges that are miles across, all the blueprints are plumbs and levels, which are horizontals and verticals. You will never see blueprints with curved lines or curved datum lines. All datum lines are parallel and horizontal, and also plumb. All plumb lines are considered parallels as well. So plumb lines are basically verticals. So
do you think this is the same case for like every terrestrial or gas sphere in the galaxy?
Well, that's the thing. Again, let me just show you real quick.
Do you think the moon is also a terrarium?
So nobody knows what the lights in the sky actually are. Nobody's actually been to them. So this is what the stars actually look like when you zoom into them. It looks like literally just lights that are twinkling in water. And these are what the planets look like. So no different than the stars. But this is what they show us. Yeah. That they're terra firma, but in reality they're not. They're just lights that twinkle. This is Mars right here. In reality, this is what they show us. This is CGI. This is NASA. So everything about the sky is basically a red herring, which means it's a false argument when it comes to proving or disproving the globe. Because nobody knows what they actually are. Nobody's been that high before to be able to prove what they actually are. So I know you airplanes and helicopters. I don't know if you knew they require to be able to push off of the air to gain lift. So a helicopter, you know, pushes off of the air. The air has to be at a certain density to be able to push off of it. The higher you elevate, the less dense the air becomes. I don't know if you knew that when you go up a mountain, the air becomes less dense and it's harder to breathe. So that's why there's limits to how high aircraft can fly, because the air becomes too thin, I guess you could say, or less dense. That aircraft cannot push off of it anymore to be able to keep going. So there is a limit, and it's around 25 miles high. So nobody's been like over 25 to 30 miles high. They claim to go thousands and thousands of miles high, but again, that's just space agencies, which are, in my opinion...
No, yeah, really, like, it's really not that high.
Well, they say the ISS is over 2,000 miles away. Oh no, over 200 miles away, I'm sorry. But again, the limit's only about 25.
space station?
The space station, the ISS, supposedly. Which again, nobody's actually in there, in my opinion. It's all just CGI. It's all done in a computer, and I mean in a room. All their filming that they do about that.
And they have their green screen. In the
Yeah,
back is the window.
pretty much. There's actually a lot of glitches on YouTube that show that they do use blue screens, green screens, augmented reality. You've heard of augmented reality, right? You could interact with CGI objects,
Yeah.
you know, in real time, for example.
So what would you say like these lights are then?
They're fascinating, but in reality, nobody knows what they actually are. You know, they are constant though. The constellations are always there every year. They always reset. So yeah, there's something's going on with the sky, obviously, but nobody knows what they actually are. You know, and what's powering them. In other words, what's giving them their light. You know, in other words. You know, again, they give us stories and theories of what they are, but it's all to fuel the heliocentric model. You know, the fact is, again, nobody's been outside of the Earth. You know, that's a fact. So I don't know what's outside of the Earth.
The heliocentric model as in the fact that the galaxy revolves around the sun.
Yes, that we revolve around the sun and the sun revolves around the Milky Way and all of that. That's the heliocentric model.
Oh, hey! we're talking about science right now and all this stuff.
Pretty much.
Okay. Well, that's all interesting. That's
No, yeah.
What other stuff do you have in there?
So, let me see. No, sure. You guys are really interested. That's really good. So again, Euclidean geometry, blueprints. It's just pretty easy. Again, the horizon, for example, here. A lot of people think that when you elevate high, you're able to see the curvature of the Earth, but again, only through GoPros. But this is what the horizon actually looks like when you're like 20
Who got
miles.
this picture?
These are all high altitude balloon images that people have done. There's hundreds of these. Different people have done them. If you don't use a GoPro and you use a standard lens, then this is what the horizon looks like. So again, another thing about the horizon is that it rises with you as you elevate. If the ground was truly curving down away from you, like at sea level, for example, when you elevate, that horizon shouldn't rise with you. You should literally start looking down at the horizon, but you never look down at the horizon. It rises in front of you. You don't even when you elevate, you increase your angle of view, and you're able to see further in front of you. And that's why the horizon is always just the limit of perspective that's in front of you.
So you're saying that NASA, the government, they've admitted to this being CGI,
Yes.
this being tampered
Yes.
with?
The only one they claim that supposedly is real is from the moon landing trips that they did in 1972.
Why is that kind of surprising? I feel like that's the one that, like, if anything, it should be tampered with.
Right, because it's like back in the day when technology was less, advanced.
You know, when
could
people
say.
talk about they're like, oh, like, why is the flag moving? Like, why is the
Yes,
flag
because there shouldn't be any wind up there.
Yeah.
Yeah, there's a lot of anomalies with the moon landing footage, like a lot. You could obviously see wires too that the astronauts have. You see the reflection of wires when they're walking and they trip over and then they kind of come back up again. It's just so fake that it's laughable, the moon landing. But they admit the only one that, in my opinion, that image that they have from 1972 is a photograph of a painting, in my opinion. So an artist created like painted basically a globe, in my opinion, and they basically just took a photograph of that.
So you don't think the moon landing too?
Oh no, 100%. Yeah, there's no way. Again, the moon, they tell us that it's terra firma as well, that you can physically land on it, right? But again, nobody knows what it actually is. In my opinion, it's just some kind of LED light, And I'm saying LED light very like ignorantly because that's the closest thing that I could think of. But the technology of what the Earth is super advanced that we can't even comprehend.
So you think we're projecting that into the sky?
I don't think we as humans, I think whatever created this place. Yeah, so there is definitely some kind of God. I don't claim to know what that God is because in my opinion, that's just religion, which is what, again, anybody trying to tell you what this place is and how it came to be is just a religion.
Yeah.
So the globe Earth model, the whole heliocentric, why is a religion? Because that's no different than Christians being told what this place is.
Yeah.
Again, the only difference is that they're claiming that what they're saying is real, but it's not. So again, the whole globe Earth is a religion. It's based on faith. You have to just believe it blindly. So again, and the sun, same thing. Nobody knows what it actually is. In my opinion, the sun is actually very small in comparison to the Earth, and it just moves. Yes, and it just moves around the Earth, and it only illuminates the area it's above. And that's why we have night and day.
So then it's not heliocentric.
It's not heliocentric. It's geocentric. So everything revolves around the Earth instead. But again, they tell us that the sun is like 500 times bigger than the Earth, or I don't know how many times bigger.
Yeah.
In reality, it's the other way around. It's way smaller than the Earth.
Why is it revolving around the sun?
I think it has something to do with
because of gravity, or is that...
No. I think it has something to do with the electromagnetic field here on Earth, because there is an electromagnetic field.
Isn't gravity magnetic?
No, they claim that it's magnetic, but magnets only affect metal, right? They're claiming gravity affects all matter equally, which that kind of force doesn't exist. That's what I'm saying. A force in free fall has never been measured because that kind of force doesn't exist. So imagine, for example, you know how we're saying that matter always reacts to acceleration?
Yeah.
If I accelerate this direction, we know that it's going to get pushed in that direction. You see that? This will always...
pushed this way first.
Yes, exactly. So they're trying to say that there's a force that exists that can accelerate this container without any reaction of the ball inside. That kind of force doesn't exist. Now imagine a gravity
You're
machine.
talking about gravity.
Yeah, if we're talking about gravity, imagine if they actually did have a gravity machine, they should be able to accelerate this without any reaction. But again, this will always react, always, 100% of the time. It will always get pushed. Because in order for this to be able to move, that motion creates a pressure inside this water, and that pressure basically pushes anything that's less dense. So you can't have acceleration without pressure. And that's what they're claiming, that you could have acceleration without pressure, which defies physics, in other words.
So then what do you think is the force that's like always keeping us on the ground?
Again, it's the continuous motion of the earth moving up. That's
it's like catching up to
yes,
us?
yes. So when you jump up, people think that you come back down, but it's simply the earth catches up. Yes, the earth simply catches up again.
What do you think would happen if we all jumped at the same time? Just hypothetically, like
Right,
like
right.
that question. Like, what do you think would happen?
Yeah, like...
I mean, I don't think anything would happen because I don't think we have enough mass to be able to stop the motion of the earth. So I don't think.
So
nothing
how
will
does that
happen.
work? Like, how is like? Are you saying like the Earth is always constantly moving up?
Yes, it's always constantly moving up like that. Now, a lot of people say, oh, it has to be moving up through infinite space. And the fact is, I don't know the exact motion or speed of the Earth.
So, okay. So, like,
So-
if I jump in the air and then I go back down on the ground, it's because the Earth is, like...
Catching up to you.
So, does that mean, like, they are, like...
Should we all
also
jump at the
moving
same
up to me?
time?
So, like, if I jump, boom, I just jumped. The Earth and then
They caught up to you,
they're
too.
also
Yeah,
catching
because
up
they're,
to me?
yes, because they're connected to the Earth. Exactly.
Alright.
So let me show you this real quick. That way you could... So buoyancy, right? Remember I told you that buoyancy, it's the upwards push of the Earth. It's a chain reaction of a push. I did this experiment with a slinky and a ping pong ball in a
I love
container.
slinkies.
Yeah. So when I'm holding it right here, for example, we can see that the ping pong ball stretches the slinky because of the buoyant force when connected to the Earth. As soon as I release that container into free fall, that upwards buoyant force vanishes and the slinky contracts and the ping pong ball gets pushed down because the slinky retracts. So that upwards push vanishes when it's not connected to the Earth.
So, are you saying, like, this is just kind of like a visual representation of, like, it catching up?
Yeah, so the slinky being stretched up by the ping pong ball shows that the ping pong ball has a buoyant effect right now when it's connected to the Earth. But as soon as it's not connected to me or the Earth, that upwards push of the ping pong ball vanishes. It's only there when you're physically connected to the Earth. That chain reaction of motion vanishes, in other words. So again, it's literally the Earth pushing up on the table right now, which is pushing up on this bottle, which is pushing up on the water, which is pushing up on the ball. So that's what's making this ball float. It's that chain reaction of a push.
So, like, a plane taking off and then landing, the plane landing, that's the Earth catching back up.
Yes.
Because then that kind of makes it to where, like, the Earth is kind of working in regards to, like, us and everything else, where I feel like, I don't know.
Yeah, so if a helicopter, obviously it's pushing off of the air to gain altitude. If you turn off the engine of a helicopter, again, it's literally the Earth that comes up to crash into the helicopter. It's not the helicopter that crashed into the Earth. So like, same thing with airplanes. When they're flying level, for example, once they gain altitude and then start flying level, what's happening is that the only way that they're maintaining level is they have their nose slightly pointing up, like 1 or 2 degrees. And also the wings the air is pushing up on the wings, which is creating a buoyant effect as well. And that's how an airplane is able to maintain level flight, by slightly pointing its nose up and also by utilizing the wings and the air pushing up on the wings. So again, it's all utilizing the upwards push. It's an upwards push. That's what buoyancy is. You can look it up. It's an upwards push. And it's a real force.
Yeah.
In free fall, however, something that's in free fall, there is no force there. And that's why gravity is just a theory again. The force is up, not down. Measurably, testably. So everything shows us that, basically. Again, like I showed you with the accelerometers as well.
Yeah.
You guys want to see the 2-minute video real quick that I did with an accelerometer?
Yeah, let's hear it real quick.
Real quick before you guys go.
How was your study?
It's good. Yeah. Next class, like, we gotta go soon.
Okay,
2-minute video.
experiments, here it is.
It's supposed to know.
Here it is.
digital accelerometer is a device that detects the presence of a force or acceleration. For example, when at rest and connected to the Earth, it detects 1 g-force. As soon as I accelerate it from being at rest, the accelerometer detects that acceleration by increasing the g-force. Whether I accelerate it to the right, to the left, up, or down, the accelerometer will always detect the acceleration 100% of the time. However, the instant I put the accelerometer into freefall, it detects a deceleration. It goes from 1 g down to 0. If the accelerometer was accelerating down in freefall, it would detect that acceleration by increasing from 1 g, not decreasing. Not only does the accelerometer show that there's no detectable acceleration in freefall, it also shows that the vector or force of the Earth is up. When I switch to the vector tab of the accelerometer, we can see when at rest on Earth, it detects that the vector or force is down, as shown by the green line. However, the vector on the phone is inverted because when I apply a force to the right, the vector goes to the left. And when I apply a force to the left, the vector goes to the right. When I apply a force down, the vector inverts up. And when I apply a force up, the downwards vector increases, showing that the vector on the phone is inverted from the true direction of the force, or vector. So when the phone is at rest on the Earth and knowing that the vector is inverted, the direction of the force or vector is up. Also, when the accelerometer is in free fall, the vector completely vanishes, showing that it's not being accelerated down by any force, which proves that the force or vector of the Earth is up, not down.
So you guys seen the little green line, right? That's kind of showing the direction of where the force is being applied. But when it's in free fall, that line vanishes. So there is no detectable force in free fall. So again, that literally shows us, that there is no force in free fall. Not only that, the digital accelerometers, but analog accelerometers, which is different states of matter inside a container, and you accelerate the container. That matter inside the container should react accordingly to the direction of the force, which doesn't, again, in free fall. Like when I show with the bottle, the ping pong ball and the steel ball. Yeah. So again, everything shows us that there is no downward force. And again, that's required for the globe Earth to even be, to even exist. And again, that's where, in my opinion, this whole motionless flat Earth thing is all controlled, because they're kind of keeping that idea alive that there is a downwards acceleration, even though we can't measure it. But that's just to give, basically, to give credence to the globe as well. So now they're debating this false dichotomy. In other words, it's a false debate. In other words, it's being controlled. Both sides are being controlled. Yeah, so yeah, man. So that's the number one lie on Earth. That there is no pulling force of gravity. It's a push.
And that's what I've been saying. All right, thank you
so
so
man,
much.
appreciate it. All right, guys, take care. Bye bye. All right, there you go.